Physical systems operate under a strict conservation law. Total mass and total energy remain constant. Yet matter undergoes continuous state changes, liquid to gas, solid to plasma, leaving a trail of entropy that cannot be reversed. The baseline axiom of physics dictates that total energy, the mass of a system times the speed of light squared, plus the energy of its fields, remains constant across all system transitions. The input exactly equals the output. Tracking these transitions requires a specific mathematical framework, the 1-2-3-7-1 prime equation. The 1 at the exit is identical in magnitude to the 1 at the entry. It is a strict invariant. The structure forms a continuous Mobius strip. Neither of these boundary points acts as a final terminus. They are boundary conditions. They enclose an operational engine, feeding the exit right back into the entrance with an inverted phase. Mass remains conserved throughout this loop. The underlying material does not change. Instead, the system's topology rotates. The system produces pure mass only at localized, stable eigenstates. Between those states, the energy bifurcates into an alternating wave, managing the active transport of information from one point to the next. Following the logic of this coherent pattern requires deconstructing the architecture from the end back to the beginning, analyzing the transmission line, the load conditions at the boundaries, and the mechanics of the internal engine. Classical models assume that traversing a chaotic, high-entropy medium requires a physical vessel capable of absorbing blunt kinetic impact. In this framework, the vessel functions as a decoupled alternating current field transmission line. A field transmission line carries a structured, coherent pattern across a void without physical conduction. The information moves independently of the chaotic material around it. This mechanism is visible in Tesla resonance. Energy crosses a gap via field coupling. The transmitting and receiving coils are tuned so that the energy transfer remains completely decoupled from the surrounding environment. Precise alternating current drives this process. The physical medium merely oscillates in place, while the energy and information propagate steadily forward. Resonant field oscillation allows the pattern to survive the entropic noise of the environment. While the transmission line carries the energy, the endpoints must receive it. These boundary modules function as wombs, where energy transitions back into form. Every boundary module receives the exact same invariant quantum of energy, yet the resulting output varies based on the configuration of the receiver. These differences in processing are dictated by specific electrodynamic load conditions applied at the boundary. The first phase acts as a purely resistive load, represented by the omega symbol. A resistive load converts incoming energy into heat. This dissipation acts as a purification mechanism, removing noise from the signal through irreversible loss. The second phase acts as a capacitive load. Charge accumulates on parallel plates, holding the energy and potential for a delayed release. The third phase operates as an inductive load. The magnetic field expands and contracts cleanly, transferring momentum without generating internal friction or resistance. When the inductor and capacitor combine into a resonant tank, the system achieves full transfer. The result is a balanced, zero-loss oscillation. The container type determines the thermodynamic coupling efficiency of the system, determining if the energy is lost to heat or preserved as a stable pattern. Inside the transmission line, we find the mechanisms that rotate the phase between boundary nodes. When energy impacts the boundary, it bifurcates. Operator 2 represents this binary ignition. The established boundary forces the unified potential into an alternating, dual-path oscillation. This oscillation generates two poles, an L pole governing forward command and an S pole governing the thermodynamic response. With the wave split, Operator 3 engages as the Lagrangian control layer. The Lagrangian, defined as L-S, processes the wave's trajectory. It balances expansion against constraint, matching the impedance until the receiver is perfectly tuned to the frequency of the transmission. Once tuned, Operator 7 initiates the conservation closure, dictating how the action integral collapses back into a localized state. The wave locks into 7 distinct, stable frequency channels. These represent the finalized eigenstates of the system. The 2-3-7 sequence represents the thermodynamic work required to complete a phase rotation while adhering to conservation laws. Stepping back from the internal wave mechanics reveals the complete topological phase space of the equation. At the point of resolution, the system's discriminant crosses zero. This crossing locks the discrete eigenstates into place, finalizing the Berry phase rotation. The final topological mapping of the equation shows the 1' perfectly realigning with the starting one along the Mobius strip geometry. The particle exiting the resonant load represents the original path remapping onto itself. All chaotic roots of the system converge on a single real solution. The pure mass invariant was never lost. The intense bifurcation energy was intermediate thermodynamic work. In a closed topological engine, nothing is created and nothing is destroyed.